Oh, yeah, that's good. That's a good idea. Anyway, thank you for inviting me. You know, I guess y'all can see this, the start slide that I'm going to try to focus my talk, my presentation, which is going to be brief, about climate change and pollen. As y'all know, I'm an allergist, so clinical. I'm a clinician, and so I see patients. And in that capacity in our clinic, we do the pollen counts on a daily basis, and we report them, in fact, for free, daily here in Atlanta for of what we're seeing. So you can go on our website, atlantaallergy.com, and just see the pollen count. And the reason that we do follow pollen counts is because patients who have allergies, we need to figure out what's triggering their allergic symptoms. So we see patients with, respiratory allergies, hay fever or asthma. And if their symptoms flare at certain times of the year, then, we need to figure out what's in the air at that time, potentially making them, sicker, or, having allergic type symptoms. And that's where you get the, the correlation with the exposure to pollen and the respiratory illness. This may be basic. I don't know exactly. Is this too basic for, we're all doctors, I guess, or all clinicians, right?
Yeah, that's right. Most of us,
Okay.
we may be in different specialties, but yeah, so far I think all of us are clinicians.
Okay, good. So anyway, so that's kind of an overview that may be a little basic for everybody, but that's why we do pollen counts, to try to figure out what's causing it. So, I know the purpose of this organization is to look at the effect of climate change and, impact on health. And so I thought I'd go through just a few of the articles recently that I think are, germane to that topic. And one of the first ones that came up was published from the Italians in the Annals of Allergy in 2010, looking at the possible role of climate changes and variations in pollen seasons and allergic sensitizations during a 27-year period. So these allergists who are in several cities in Italy, I know that Walter's in Genoa, and I'm not sure, I think Pasquale is also in Genoa. But anyway, the bottom line is they're measuring pollen counts. They recorded the pollen counts for, in the season duration. And they also looked at prevalences of the sensitizations. They looked at 5 major pollens. And in Italy, birch, cypress, olive, grass, and this parataria, which is a flowering weed that we really don't have here, but they have it in Europe. And they collected it, and then they analyzed, what was happening with the, with the pollen. And this is one of the things they found. If you look at this slide on the left, it's the percentage of, this is the parataria, and I'm not even sure how to pronounce it correctly. We don't have it here, but you can see the pollen counts from 81 through 2007 increased significantly during that period of time. I mean, there was a fluctuation, but if you look at the average, there was a trend. Same thing with the duration of the pollen season. So what you saw is a longer pollen season, and this is the number of days, and then a higher pollen counts. And this was not only true for that weed, but also for olive tree, which also had longer season duration, and total pollen counts increased as well. And when you looked at the reason for this was the temperature. So they correlated this with temperature because they felt that the average days with a temperature greater than 30, this is centigrade, of course, in 81 was here was 20, roughly 23, but you could see how it trended higher during that 27-year period. And those are the days with the higher pollen, the higher temperature. And you can see the actual temperature correlated as well. So the conclusion that Walter and his colleagues came to was that considering a very restricted and homogeneous geographic area, obviously just in Italy, and Genoa, I believe they were. But a sufficiently long period of time, there were some climate changes observed even over the 27 years. And the changes were accompanied by an increased pollen load. We saw higher counts, sensitization rates, which I didn't show you that data, but they had some data which was a little soft on that, showing that there were more patients reporting allergies during that time. And then they suggested that there was a direct role of climate variation in the epidemiologic impact of pollen allergy. So that's one of the first studies, at least by clinicians that I know of, about pollen and climate and temperature. We reported last year in collaboration with the folks from the CDC, and we shared our data for the 27-year period that we had between 1992 to 2018. And we looked at, and we reported this in the Annals of Allergy last year, long-term pollen trends and associations between pollen phenology and also seasonal climate change in Atlanta. Okay, and so what we did here, this is our abstract. Basically, we did cite that there was prior research that did reveal that airborne pollen concentrations in phenology and allergenic plants are changing, and the variations of seasonal climate are known to affect pollen. And we decided, what we did is investigate the local trends in pollen concentration, the pollen phenology, and also over time, and the effect of the seasonal climate variations. We used the daily pollen counts, which we did in our offices. We're part of this National Allergy Bureau. And we looked at the 13 of the allergenic plants and evaluated the long-term trends over time, developing a linear regression model for 6 pollen measures. And then to evaluate the effect of the seasonal climate on the phenology, we developed regression models using seasonal climate measures as independent variables and pollen measures as dependent variables. So the results were that for several tree pollen taxa, pollen concentrations increased over time. The main one was oak and also juniper. Other species, pollen seasons tended to trend with earlier release throughout the 27-year period. So we saw the pollen starting earlier, and then the variations in seasonal climate did have an effect on pollen counts, higher pollen counts, and timing of pollen release, but it did vary by the taxa. So generally the warming spring weather, spring temperatures were associated with an earlier pollen release, and in addition, increased precipitation from the preceding fall was associated with an increased pollen concentration in the spring months. So, when we talk to people and they say, oh, before our spring here in Atlanta, which y'all are here, y'all know about our spring in Atlanta, they, frequently the press will come and ask me, well, can you predict, is this going to be a terrible spring? Well, now we have some data that looks like if there's a lot of rain in the fall and in the winter, you get higher pollen counts in the spring. Anyway, let me show you some of the data, which I think is really compelling. This is the increasing linear trend in spring and summer average temperatures, and it's shown with a red line. Obviously, winter, it's kind of all over the place, but the spring clearly had a clear trend. The same thing with summer. Fall was a little bit all over the place as well. And these are the coefficients of variation in the gray. The scatter plots of the pollen count, the average daily pollen counts over time, and you can see this is for all the trees. So if you look at the top left box, the average daily pollen count, here you could see how significantly it's increasing, or how remarkably it's really increasing over the 27 years that we studied it. Some were more than others. Oak was really dramatic, and that was almost 5% a year an increase, which is incredible. Some of the others like sycamore and even pine, which didn't really increase as much over time. Birch, I'm a little surprised to see birch didn't change that much, or elm. I can't explain that. Birch is a big problem here. Grasses, interestingly, didn't seem to have that trend, and we see those a lot in the later spring and early summer and through the summer in Atlanta. Bermuda grass pollinates through the summer in Atlanta, so we don't see as much of a correlation there. But oak increasing 5% a year was dramatic. So in conclusion, we characterized the pollen for 13 different allergenic taxa, where there were trees, grasses, and weeds, and in both spring and fall, and found that many allergenic pollen exhibited an increasing trend in pollen concentration, and that the pollen phenology is shifting. And we found that pollen concentration and phenology is also associated with the year-to-year variations in climate change, in seasonal climate rather, which could be useful for future development in predicting pollen models. And the results of our analysis suggest that changes in seasonal climate, that is the warming of the seasonal temperatures, could hasten the timing of pollen seasons and increase pollen concentrations, increasing the risk of allergic diseases like asthma and things like that. So that's, data that we published and has been presented. Now, this is an interesting article that came out earlier this year in the journal Nature Communications online, and this is a projection. This was we mentioned that in our article, but projected climate-driven changes in pollen emissions, seasonal length, and magnitude over the continental U.S. And this is out of the Climate and Space Sciences Engineering over in University of Michigan. And what they did is they did a simulation with a pollen emission model and future climate data, warmer end of century temperatures, and a shift to start spring emissions 10 to 40 days earlier, and the summer weeds and grasses 5 to 10 days later, and lengthening the season duration. And what happened, the phenology shifts depend upon temperature response and the individual taxa, with a convergence in some regions and divergence in others. So there were, some of them didn't, weren't as, convincing as others, but that's, what we kind of found as well. But the temperature and the precipitation alter the daily emission, between 35 or minus 35 to 40%, and increase in the annual total pollen emission by 16 to 40% due to changes in the phenology, temperature-driven pollen production. They also cite that increasing atmospheric CO2 may increase pollen production, and that doubling the production in conjunction with climate increases, end of century emissions could be up to 200% is what they're projecting. They did mention about land cover changes and the distribution of pollen emitters, but they felt that was relatively small compared to the temperature or the climate and also the CO2. And these simulations indicate increasing pollens and longer seasons are likely in the future. This is a graph from it. It's a difficult graph the images looking at the historical changes in temperatures, and also in the future. This is the CO2 in different areas. I'm not going to go through this in that much detail. The bottom line was that they felt that they project that the future climate scenario, the pollen season will start up earlier, even up to 40 days earlier. Now, we found it was like 5 days. It would become longer, more than 19 days longer, with temperature change, and the annual increase in pollen emission could also increase 16 to 40% over the US. The climate-only driven changes are small, whereas the maximum emissions are probably more because of CO2 in pollen emissions. So here's what they're projecting is that CO2 is more important than temperature, even though when we studied it, we didn't do it quite as long and we didn't have as much data on CO2. They also mentioned about land cover, can increase or decrease future pollen emission maxima, and they felt that that's really of small magnitude in terms of the pollen. And in fact, that is as well. We did cite that and look at that in our study because, we're in Cobb County and there's been a lot of growth in Cobb County over the 27-year period as well. So let's see, oops, where is it? There we go. So the bottom line was that they felt that the potential climate change impacting CO2, temperature, precipitation on pollen emissions over the US, they felt that clearly the CO2 is going to be a very important effect, and that we're going to have higher pollen counts And, that's basically what they, what they their conclusion was. I don't know if you all saw that study. It got a lot of press at the time because it was in the middle of our spring pollen season around May. I think it was April, or maybe it was March or April when it was published. But there have been some other studies looking at pollen. In fact, that there has been one study that I didn't have time to put together showing that this was in a simulated lab. They found that when pollen is grown or plants are grown in a higher CO2 environment, their pollen is more allergenic. So higher CO2, not just more pollen, but more allergenic pollen. So for patients with allergies, global, the warming trends and climate warming is a very significant problem because of these allergens and the fact that, it can cause more disease and more allergic sensitivities. So I wanted to throw that out as food for thought. Hopefully I didn't tie up too much time for our discussion, but I guess Neelu, it's your turn to present something, right?
Yes.
Yeah.
Thank you, Dr. Fineman.
Thanks, Dr. Fineman. Yeah, that was great. I think, why don't we do that? That'll probably be easier if we just, Neil, move on, and then maybe we can have discussion. You guys can both tackle some of the questions that come up, but I do want to introduce you before you get started. So Neelu Tummula, she's an ENT physician, excuse me, and she's the co-director of the Climate Health Institute at George Washington University. She's on the steering committee for the Virginia Clinicians for Climate Action, and I want to welcome some of our colleagues from up there. She has completed a fellowship with the Yale program on climate change communication and the Op-Ed project, and has a focused interest in climate change advocacy work. So with that, I will turn it over to you.
Great. Thanks, Mehul. Thank you for the invitation. So I am at George Washington University, but I grew up in Georgia. We lived in Douglasville and Peachtree City, and now my parents live in McDonough. And a quick shout out to my sister, who's a cardiologist, but is joining us today. So I do have one cardiology slide because everything is interrelated when it comes to climate change. And yes, it's great to see some VCCA members here as well. So I'm going to talk about climate change and allergies, but I'm going to approach this from the ENT patient. I think that most people are familiar with this slide from the CDC, and really this is a really great sort of global view on how climate change impacts health. And there's two main areas I'm going to be focusing on with the ENT patient. So one is over here in brown, which is increasing allergens and how that affects respiratory allergies and asthma. And then I'm also going to be talking about air pollution and how that impacts asthma and cardiovascular disease. Because again, when we're thinking about ENT patients in particular, we're thinking about allergic rhinitis, but then we're also thinking about what impacts them from a perioperative morbidity and mortality standpoint. And that's when cardiovascular disease and respiratory health are incredibly important. So as Dr. Fineman was talking about, there is a really strong connection between temperature and environmental pollens and allergic rhinitis. And temperature is one of the strongest predictors of atmospheric pollen concentration. And global warming has been linked to lengthened pollen growing seasons, pollen growing in new geographic regions. And so this is a trend that we see a lot with climate change and other health impacts. So especially like infectious disease, as we're seeing West Nile virus appearing in more northern latitudes as temperature and precipitation patterns change. The same is true for trees being able to, trees and plants growing in new geographic regions, which is allowing pollen to then appear in new areas. And then just the increased concentration of pollen in the environment. And again, as Dr. Fineman said, this is both linked to temperature and to CO2. And I have also seen that study that you alluded to with increased CO2, increasing the allergenicity of the pollen. It's really interesting. And again, I think that just shows how many different ways that temperature, precipitation patterns, and CO2 are affecting our allergenic population. So this is a study from the Proceedings of the National Academy of Sciences, and it was published about 2 years ago, that basically is looking at what is the anthropogenic climate change contribution to the trend of different pollen levels. And so this basically looked at long-term pollen data for 60 North American stations over 1990 to 2018. And so on the x-axis here, they have both the long-term intervals and the short-term intervals for the annual pollen integrals and then the spring pollen integrals. And then over here, they have the start date to the pollen season and then the season length. And so basically this study found that on average, there are about advances in lengthening of the pollen season that's about 20 days. So this correlates to one of the studies that Dr. Fineman had showed, which showed that on average is about 19 days. Although again, there is a range that these studies are finding. And then this study showed that there was an increase based off of this North American pollen data, increase in pollen concentrations of about 21%. And so again, that fits into that interval that was shown of 16 to 40% on the prior study from earlier this year. And what this study in particular was trying to show is what exactly is the anthropogenic climate change contribution to the trends that we're seeing, right? Because there are a lot of different factors. And that's one of the arguments that some may make, is that it's not just climate change. There are multiple factors impacting these pollen trends. And so this study found that approximately 50% of these trends can be attributed to anthropogenic climate change. So this is a study that I really like because it is a reminder that just because pollen levels are increasing, they're not increasing the same everywhere. And so this kind of always takes us back to the conversation of thinking about environmental inequities, and that some people are exposed to certain climate impacts more than other people. And so this was a study that was published in the Journal of Allergy and Clinical Immunology. And so if we look over here at the graphs, the yellow is basically farm area. And so that's like a very rural environment. The green is parks. And so that is a semi-rural environment. And then the blue, so this was done in the DMV area. So the blue is Towson, which is a suburban area. And the red is Baltimore, which is an urban area. And we have here the biomass at flowering, and at the bottom graph is the catkin length. And then basically they were looking at both the biomass at flowering and the catkin length based on the increase in average temperature and the increase in average CO2. So in general, when we're comparing temperature and CO2 in the study in the urban versus rural environments, CO2 levels were about 30% higher in the urban areas, and temperature was about 1.8 to 2 degrees Celsius higher in the urban areas. And, you know, there are multiple factors for why urban areas are warmer than rural areas. You know, and I'll touch on this a little bit later when I talk about air pollution inequities, but, you know, rural areas have a lot more green space on average. They have a lot less concrete on average. And then, of course, we also have to think about, you know, a lot of urban areas have historically been redlined. And so this was, you know, these housing practices back in the 1930s to 1950s, where historically Black neighborhoods were redlined. So basically they were drawn out, and those were deemed unsafe for investments from lenders. And so a lot of those communities today that were historically redlined now are areas, one, with historically or with more communities of color living in them, but they also tend to be the ones that now have a lot less green space, a lot more concrete. And then there also is a lot of like highways that have been built near those neighborhoods, again, just based on historically racist practices within our highway system. And so I'll get into that a little bit later. But basically this study in particular, with this increased CO2 and the increased temperature in these urban areas, found that, and this was on ragweed specifically, it grew faster, flowered earlier, and produced significantly greater above ground biomass and ragweed pollen at the urban locations than at the rural locations. So again, this is just one of those gentle reminders that not all of our patients are feeling the same impacts from climate impacts, and that where they live can have a huge impact on what they're suffering from. So I'm going to shift gears slightly and talk about air pollution in these next couple of slides. So air pollution and particulate matter specifically is what I'm going to focus on for these next two slides. So particulate matter is one of those where there's a lot of like really good data that's been done on it. And so, the size of the particulate matter is really important. So some of the larger particles, which is like PM10, which is particles that are less than 10 microns in size, those tend to get lodged in the upper airway. An average, this is just to give a little bit of reference, an average human hair is about 50 to 70 microns. And then you have smaller particles, which are PM2.5 particles that are less than 2.5 microns, and then ultrafine particles. So those are particles that are less than 0.1 microns. And so the PM2.5 tends to get lodged in both the upper and lower airway. And then the ones that are less than 0.1 microns, the ultrafine particles, those are so small that they can cross the blood barrier and then enter the bloodstream. And that's how we get a lot of the cardiovascular impacts from air pollution. And all of these particles, PM10, PM2.5, and ultrafine particles, some of the main emission sources are from our highway system. PM2.5 levels are also increasing with increasing wildfire smoke, power plants, and then ultrafine particles are also a huge source is tailpipe emissions. And so the reason I wanted to touch on air pollution is because I think sometimes there is a little bit of a disconnect between air pollution and climate change. But more importantly, air pollution, because it impacts respiratory health and cardiovascular health, again, that's something really important to consider when thinking about allergic rhinitis and what are the other inflammatory particles that people might be breathing in that's affecting their nasal mucosa, that's impacting their congestion, their postnasal drainage, the risk of sinus disease, but then also how are these particles impacting their perioperative morbidity and mortality. So respiratory disease and PM2.5, this is what we have a good amount of data on, but the exact mechanisms for how all of these particles impact respiratory health is still being studied. But there is substantial data that has showed that PM2.5 levels are associated with an increased risk of obstructive diseases such as asthma, increased risk of pneumonia, lung cancer, and decreased lung capacity, especially in children. So again, the exact mechanisms mostly are related to increases in oxidative stress, and then the impact of PM2.5 causing both acute and chronic inflammation on the airway system, which can contribute to, especially the chronic inflammation, can contribute to remodeling of the respiratory system, which is how it increases or decreases lung capacity. And then cardiovascular disease. And so increased air pollution. And again, it's usually the ultrafine particles, the one that are able to enter the bloodstream that increase cardiovascular risk. And so this increases the risk of heart attacks, arrhythmias, ischemic stroke, and hypertension. And so again, a lot more data needs to be collected on the exact mechanisms, but most of the studies have shown that these ultrafine particles can cause direct toxicity to the cardiovascular system, can cause localized stress and inflammation within the blood vessels, and can contribute to atherosclerotic plaque instability, which is how it increases the risk of stroke and increases the risk of MIs. And so just again, kind of going over climate change and surgical patients from an ENT perspective, because I think this constant reminder that everything is somewhat interrelated is always helpful. Some of the other things that we're thinking about as surgeons is how do major storms. So I think most of us are well aware that wildfires, hurricanes, flooding are all exacerbated by climate change. And so because global warming is contributing to both an increased severity of these natural disasters and increased occurrence, one of the main ways is thinking about the increased risk of trauma, right? So as an ENT, facial plastics, that's something that we see a lot. There's also concern for not being able to access your healthcare provider if you are living through a flood, if you're living through a hurricane or a wildfire. Actually, just on Instagram the other day, someone that I follow who's a cardiologist had posted, she said, I hope my patients can make it into clinic tomorrow. Flooding here has been terrible. And so really just sort of thinking about like, how is mobility impacted by these major storms? Pregnancy outcomes. And so prenatal exposure to both air pollution and extreme heat increases the risk of pregnancy complications, most notably low birth weight babies and premature birth, which again, from a respiratory standpoint, as an ENT, increases the potential risk of complications. And the last is, how does heat impact, perioperative morbidity and mortality, and surgical site infections. So this one specifically, there's pretty limited climate change specific data. And so what we're using a lot of now is just what has been found during heat waves, and then extrapolating that to say, okay, this is how global warming may impact surgical patients. And so we know that cardiac morbidity is known to increase during times of warmer temperatures, and that there is an increased risk of postoperative wound infections, both of which are really important to us as surgeons. So I'm going to just spend the next 2 slides touching on environmental justice, because really it's hard to give, for me, any presentation that doesn't at least touch on this. And so environmental justice itself is the principle that all people and communities have a right to equal protection and equal enforcement of environmental laws and regulation. And Dr. Robert Bullard, who is at Texas Southern University and is oftentimes considered the father of environmental justice, has one of my, I think a really meaningful quote where he says, "Today's zip code is still the most potent predictor of an individual's health and well-being." And as I was touching on before, when I was talking about the study that showed that the difference in CO2 and temperature levels in rural versus urban areas, and I talked about redlining, then I had also mentioned the highway system. And so, when the US highway system was being built, there was 2 main reasons that highways were oftentimes built near communities of color. So one, it was if you wanted to separate communities of color from the neighboring white neighborhood, or 2, it was to disrupt a community of color to try to make it less powerful. So if you just have a highway going straight through it, of course, that's disruptive to the community itself. And this is a study that basically shows that nearly, and it's a little bit of a heavy slide here, but basically in the middle here, we have Black Americans. And this is looking at different sources of PM 2.5 pollution. So from industrial coal, from heavy and light weight vehicles, from construction, agriculture, road dust, from all of these different sources, all of these sources that produce fine particulate matter, specifically this PM 2.5. Basically what the study showed is that nearly all major emission sources, and they counted for different states, urban and rural areas, income levels, exposure levels, all of these emission categories were disproportionately impacting Black Americans as compared to white Americans, most notably, but then also just in general, Asian Americans and Hispanic Americans. And so again, this is just a reminder that not all of our patients have the same exposure, and air pollution specifically, whether we're thinking about how that impacts allergic rhinitis and impacts nasal symptoms, or how that impacts cardiovascular health, respiratory health, pregnancy complications, and everything associated with that, that they are at higher risk just because they oftentimes have a higher exposure. And I like to end on a positive note. And so this is one of my favorite studies. This is a study that looked at 4,100 different children in Southern California over a 20-year period. And what it did was looking at the association of changes in air quality and incidence of asthma. And so the top graph is nitrogen dioxide, the bottom graph is PM 2.5. And basically all the different colors are just different regions that were studied in the Southern California study. And over this 20-year period, they had tighter air quality guidelines, so the air got cleaner. And what they showed, so that's what the downtrend is basically the levels of nitrogen dioxide and PM 2.5 are decreasing over this time period. And what they found is that independent of each other, the asthma incidence went down, both because of decrease in NO2 levels and then because of a decrease in PM 2.5. And so really the take home here is that cleaner air, specifically in this study, does decrease the risk of asthma. And so it's just why we're all here, why we all do the work that we do, is because there are really tangible health impacts that we can see. And this one, just in 20 years, seeing the incredible decrease in asthma incidence is pretty impressive. And that's all I have, and looking forward to further discussion. And I'll stop sharing here.
Sure. So, Neelu, do you know about the study that was done in Atlanta during the Olympics? I know you said you grew up here, but I don't know if you were here in '96 during the Olympics. Do you remember that?
I was there in '96, but I don't know what study.
So during the Olympics in Atlanta, if you recall, they stopped all traffic. They said, don't drive into Atlanta, work from home. MARTA was, they had extra routes in MARTA anyway. So here in Atlanta, during the 7 weeks of the Olympics, there basically was a drop in our traffic dramatically. And I know the study was published in JAMA a few years after the Olympics, probably in late 90s. The bottom line was they looked at the incidence of pediatric emergency room visits for asthma and pediatric emergency room visits for GI disease. Well, there was no change in the GI disease, but the pediatric visits for asthma dramatically dropped during that 7-week period. And they clearly correlated that to the drop in the pollutants from the car exhaust, the sulfur dioxide and small particulate matter and things like that. So I just wanted to, let you know about that study too. I'd have to look it up to find it, but it's sort of germane to what you were talking about.
No, that's great. I think, is that Mehul, what you just dropped in the chat? Perfect. I'll take a look.
What chat? I'm not,
Oh, I just put a link in the chat to at least the abstract of that study that you were talking about during the Atlanta Olympics.
Oh, is that right? Oh, good. Okay. Oh, okay, good. Yeah, that was the, let me just see. I'm going to click on it to see. You know what? This was not the one that I was thinking of. I was thinking of the one published in JAMA. I'm not as familiar with this one, but this is the same type of thing. I mean, it's basically the same data. The other one that's down here, the impact changes in transportation and commuting patterns, that's the one I'm familiar with because Jerry Teague, who was the pulmonologist at Emory at that time, was one of the ones behind it. That was in 2001. But anyway, you guys know where to look.
Yeah, thanks, Becca, for putting that other one in there. Thank you both for wonderful presentations. I have several questions, but before I do that, I just want to open it up to anybody else who had any thoughts, comments, questions for our presenters.
What is being done? This is Linda Walden, Family Medicine. What is being done in our communities throughout Georgia to decrease this redlining that's disproportionately affecting people of color when it comes to the air pollution and its consequences on our health? Has anything been addressed or done about that?
Dr. Walden, to be honest, I won't be able to say I know specifically on Georgia itself, but I do think that some of the provisions in the Inflation Reduction Act are trying to target these disparate exposures. I'm not sure if anyone heard, the GOP nominee from Georgia, Herschel Walker's question of don't we have enough trees around here, in response to how much investment there was in the Inflation Reduction Act towards forestry and agriculture. And trees themselves, right? When they are we definitely need more green space in urban areas. It helps cool the area, cool the temperatures, which helps decrease the amount of ground level ozone that's being produced. It also helps the trees help clean the air by trapping some of the air pollutants and then washing it away. And so I think some initiatives like that are, somewhat trying to target disparate levels of air pollution. Again, I do think there are a lot of shortcomings to the IRA, but I also think that they are trying to, the legislation is trying to invest more in environmental justice communities to be able to work on some of these disparities and work on, improving legislation so that polluting facilities and stuff have to have stricter standards in terms of how is it going to impact the surrounding community. So specifically from the communities that have been historically impacted by redlining, I think it's still a slow roll into how we're going to be addressing all of the environmental inequities. But I think there has been, with the passage of the Inflation Reduction Act, there's going to be some small changes that have the potential to make some difference.
And the reason I bring that up, because as clinicians, I think, we all need to keep in mind that, our health is affected mostly by the environment in which we live. And when we know about our patients and know from where they come from and communities they come from, we've got to be the advocate, to be the voice for the voiceless. Because if we don't speak up for them, it's not going to change. Going to our city commissioner, our county commissioners, and talking about these things and what needs to be done in our communities, such as the green spaces that will help clean that air up. It's got to stop, and it's not going to stop until more of us start speaking up and speaking out and being advocates. And that's the reason I brought that up. Thank you.
Definitely. That's such an incredible point.
Yeah, thanks for that, Dr. Walden. I will add that at the end of every one of these, we're going to try to have an advocacy piece of it, so we can sort of call each other to action and where to take it from here. And I'm going to let Dr. Jaggi take that in just a few more minutes. But before we get to that, I wanted to ask one question about bringing it back to that interrelatedness that you were talking about, but this one's a little bit more in the interrelatedness of climate's impacts on plants. Dr. Fineman, you were talking about how you can predict how bad the pollen season is going to be based on the precipitation that happens, but then also not only are allergens increased when temperatures are increased, but they are also potentially more pathogenic when the CO2 is increased. So do you know about any data in areas of the country, just hypothetically say the West, where they are obviously experiencing higher temperatures, but may also be experiencing lower precipitation rates? And how is that affecting sort of what they're seeing in terms of allergens?
I haven't seen any data specifically on that. It'll be interesting to see with all the fires and things like, interestingly, the Southeast is one of the prime areas that pollen really has a serious impact on respiratory health, maybe even more than some of the other areas, although Midwest is bad, like ragweed is pretty bad in Midwest. But I don't know of anything specifically looking at that, the drier, the lower precipitation and the higher temperatures. The interesting thing about higher temperatures, I do want to add one thing, which is we just got an abstract published. I did another collaboration with Emory, the folks at Emory in Public Health, where we're looking at pollen counts that are identified with artificial intelligence, and with that they can check the pollen count every hour. So we're looking at them every hour, and what we found was that the pollen really doesn't start rising until around noon, when the temperature gets warmer. So traditionally people thought, well, maybe, don't play outside in the morning because pollen count's higher then. Well, it's not true. It really starts at noon when the temperatures get higher. So, we've got some strong data about temperature. Obviously there's been published data about CO2. I don't know that much data about rain.
Maybe I'll ask you to follow up on that last thought, either of you. That sounds like a great piece of advice that you might take to your patients in the clinic, sort of tying in climate change, temperature, precipitation in terms of how they can modify their activities or prepare themselves for what to expect in terms of their own health. What other sorts of things do you do in your daily practice in terms of tying climate change discussions into caring for the patients that you see?
Well, we do ask our patients to monitor pollen counts. I mean, I think that's helpful. Once we identify that they have a sensitivity to a particular pollen, I think it's prudent for them to do that. We do suggest that they don't do their activities in the late afternoon. Certainly here in Atlanta in August, as y'all know, we have a real problem with with the air and the high ozone and that impact on the lung as well. So we try to keep them in an air, advise them to be in air conditioning and things like that. So those are kind of the things that we do. I don't know what, Neelu, what about you guys in ENT?
Yeah, I think similar things. The ozone, the ground level ozone with hot days is really, I think, something that we're hyper aware of just because it has such an large impact on respiratory health. I think for me personally, and I won't say that every ENT does this, or a lot actually do not, is I actually just talk about climate change as impacting their allergies so that patients are aware. Because I think one, that helps people understand how climate change may be impacting them personally. But I do use the words climate change and global warming in the clinic. And so just sort of talking about it to help people understand what that association is. With, pollen season starting earlier and lasting longer, I think also timing of their medications is something I talk a lot about. And so, Flonase, intranasal steroid, Nasacort, whichever one you're using, or the intranasal antihistamines like azelastine. A lot of times I like to start them on those medications about 2 weeks before the start of their pollen season so that they can be maximally effective. And so sometimes we'll talk about when should their medications be started, or even how long should they be continued? Because sometimes patients are like, oh, I'm fine by September. And it's like, well, you may actually need to continue it a little bit longer. And so timing of medications can also is an important discussion point.
It's interesting you say that. I forgot. I've been in practice for 40 plus years, so that's a long time. I used to tell my patients to start their nasal steroids on St. Patrick's Day, March 15th, now, or March 17th, or whatever it is. Now I tell them to start it on Valentine's Day because I want to make sure, because we're seeing the pollen sooner, they need to start it sooner. So exactly what you said. And I just, wanted to give that as an example.
And to go off of that, Dr. Fineman, I think the other thing, clearly, is like paying more for your medications, right? If they're starting it earlier and then having to use it longer, thinking about that economic impact. And the same with, worsening asthma, having to use more inhalers, or if parents are paying for more ER visits for their children, tying all of this into the economic consequences.
That's great. All right. Well, we might have time for one more question, if anybody has one, before I pass it on to Dr. Jaggi. All right, Preeti, I'm sorry I did not prepare a formal introduction for you, but Dr. Jaggi is a pediatrician here at Emory, and she also is in charge of the advocacy subcommittee for the Georgia Coalitions for Climate Action Steering Committee. And I'm going to try to help her out here. So let me get it going 1 second. All right, are you seeing them?
Yes, if you can just put it on, I think we're seeing all the slides. If you can just put it on the one slide, that'd be great.
I love the Lorax.
Me too. I'm a pediatrician, so, I have to pull in the pediatric literature.
Did it work?
I think I'm seeing like presenter mode, not the, just the one slide, but that's okay. Actually, I'm good because we don't have that much time. So maybe we can just go ahead and start. I'm Preeti Jaggi. I am a pediatrician. I also direct the antimicrobial stewardship program at Children's Healthcare of Atlanta. But we're going to be trying to pull in some pieces of advocacy at the end of all of our education talks so that we can help move along what really needs to be done, which is decreasing of burning of fossil fuels, which leads to, pollution and to climate change and any other ways that we can decrease greenhouse gas emissions. But we thought we would just pull in a couple of examples of how advocacy does work. So when we think about advocacy, I think of this as my own definition as contacting the right decision maker at the right time when critical decisions are being made that affect the greenhouse gas emissions, preferably coordinated with others for a greater impact. And when we think about this, we really want to use our voices because as clinicians, we interact with many, many different types of people. We know that mitigating emissions is really good for people's health, and healthy habits are synergistic with decreasing carbon emissions. So can you go maybe one more further? Perfect. Keep going. Oh, I think this might be an old slide set. So you can keep going, Mehul. I'm just going to talk maybe we want to, again, use our voices because we interact with so many different people. You can go to the next slide. And when I think about advocacy, I do a lot of advocacy at a lot of different levels. If you were a new advocate, new into trying to advocate for system change to decrease climate emissions, if you think about who should you spend most time with, is it the person who's, who loves coal on the left, or the environmental advocate on the right-hand side? I would suggest that we start really paying attention to what a lot of environmental advocacy groups are doing, or at least because they're able to tell us what are the critical issues that are occurring on every different level. And I would say that we should really focus on the fact that there are lots of small changes that can add up, and to really advocate for local change. So I wanted to give a couple of examples about some local changes that you can, to give some examples about what we can do. I live in the city of Decatur in Georgia. We had worked with the city. They do a strategic plan every 10 years. And we decided that we wanted the city to have a climate and energy plan. So we got into that strategic planning process, which was already something that the city was doing. And as a result of that, they created a plan that includes a climate and energy plan, and actually contracted with someone. And this was a really, really good effort in our town. Our city schools are now up for their strategic planning. And so we are working on advocating to the city schools about electric buses, about a climate and energy plan. And we can then let's say, oh, look what the city of Decatur did. That is a good example. In the fall, we're going to be doing a lot of work with Mothers and Others for Clean Air, which is an organization here in Georgia, to also help facilitate and advocate for electric school buses for school children, which is better for their health and the community's health. That's something that, pediatricians and healthcare workers can certainly get behind, because it is going to be better for everyone's health. And then really trying to liaison with others who are going to help the school systems understand what kind of the infrastructure is needed to be able to make that kind of a change. And then one more thing that we worked on in our healthcare system is to advocate to our healthcare system to join Practice Green Health. And that was really, that advocacy to join Practice Green Health really came from physicians, some of whom are on this call. So I think that it just gives you an example that local decisions with advocacy, with voicing our concerns, really can make an impact. A couple of other things just to think about are businesses. We know that Amazon employees have pushed for electric vehicle delivery vehicles and other changes at Amazon. We know that people have advocated to other businesses to decrease plastic waste. And some of these businesses have responded. And really, we can consider our hospital systems, they are businesses too. So one of the things that I recently worked on was, we have a doctor's cafeteria, and they were serving everything in foam and terribly, terrible for the environment kind of packaging for the food. And actually myself and others have been advocating to just get better compostable dishes, and they actually just responded with that. And of course we would like, not disposable dishes ideally, but they did respond by making that change. Another thing just to think about at the state level, we have been working with our Public Service Commission, and that is a really, really important group of 5 individuals that regulate our energy mix for the state of Georgia for about 2/3 of the power generated in Georgia. And we have been working with them about advocating for more renewable energy. And we just recently went through an integrated resource planning process. And actually they did make some changes for a more energy efficiency, which we're really, really advocating for especially lower income folks. And then just finally, at the federal level, we know that there was lots of advocacy being done that ended up with the recent action by Congress. And that was after lots and lots of work by lots of different people and lots of advocacy. One other piece of information on the federal level is the advocacy that people have done for postal vehicles. The Postal Service was going to be getting many diesel vehicles, and after a lot of environmental groups and petitions and all these kinds of things, they decided to get 40% of these vehicles will be now electric, and people are now pushing them for more. So we just wanted to give a couple of examples of how advocacy can help move things along. And after many of these educational sessions, we will try and put out timely advocacy efforts that you can participate in, and that we can all do in a coordinated manner to increase the impact. And then I will stop there.
Okay, thank you so much, Preeti. And thanks to everybody for joining us. This I think was a wonderful way for us to kick this off. And like Becca said, we hope to build on this and continue to have great presentations and presenters like we did today. Thank you guys all so much for coming.
Thank you. Thanks for setting
Thanks
it
a
up.
lot.
Thank you.
Thank
Bye.
you.